Hi, so I'm one of the conservators at York Archaeology, and today I'm going to be speaking about assessing the condition of archaeological small finds. And I'm using a methodology here that we've been trialling at York for the past 2 years. It works. So the condition assessment forms part of the conservation element of the wider post-ex assessment. It's probably quite familiar to everyone here, and it's one of the most common pieces of work we do at YA. As well as including X-radiography and advice for archival deposition, it should also involve a condition assessment of the finds. So what is a condition survey? So prior to working at YA, my experience was predominantly in museum settings, so at the other side of the archival deposition process. And as part of that, I was often called to perform condition surveys. This is a rapid assessment technique for when you have to very quickly do a condition assessment for a collection of objects. For instance, a collection coming off display or a collection going on long-term loan. And it involves giving a condition grade as exemplified beautifully here by Henderson. And it can be adapted to specific collections or museums. The Science Museum in London, for example, a good condition grade means mint condition and in the box. I don't think any of us are getting that anytime soon, but we can dream. So I wanted to see, can this be adapted for small finds? Which would be particularly handy when we're doing a large assemblage of objects, and it gives focus to key features of the object being assessed, which can in turn help with determining resource allocation for specialists. And it also provides a data set. So usually condition data is kind of qualitative, and when we make it quantitative, we can make much more quantitative evaluations of the different material classes in an archaeological site. Okay, so this is the classification adapted for iron. So when we assess metals as conservators, we're usually looking at X-rays to determine how much of the material has been mineralized, how much of the original surface is left. Unacceptable. This is when you have complete mineralization of your object, when you've got a finds bag with just scraps of iron in it. Poor is extensive mineralization, more than 50%, some active corrosion, when you've got that voluminous red-orange corrosion products. And then fair, the shape of the object is well defined, but there's some mineralization, less than 50%. And then good is you've got the object, you can see the shape, and there's no active corrosion. So this is a condition assessment of a nail before this methodology is applied. It is a technically good condition assessment. It's not one of mine, for full disclosure. There are a lot of key details, but they're kind of hidden in this wall of text. And this is for the same nail after applying the methodology. So as you can see, it's positively identified as a nail. There are no minerally preserved organics or MPOs. And it's a lot quicker, and it gives you the information you need. So just to put this into context, this particular assemblage had 1,266 iron objects. 1,207 of them were nails. So when you have something like that, this is obviously a lot quicker than this, and that has massive cost-saving implications when resource funding is always so limited. And this is the condition scoring when applied to glass. So similar to Phil's glass previously, unacceptable is when you've got complete delamination of a substrate, with losses is due to flaking, iridescence in multiple layers, going right through the body of a sherd. Poor is when you've got some disfigurement, more than 50%, perhaps from metals corroding close proximity. You've got some delamination, but it's not penetrating right the way through. Fair is structurally stable, little bit of iridescence, And good is structurally stable, no iridescence, no massive scratches, no impact damage. You can see what it is. And again, I've got the before of a condition assessment of these particular sheds, and then after the methodology is applied. So the key features are really visible here. There are 4 sheds. You have a colour, it's brown. You've got a painted on design in red, and the pieces fit together. You're not having to search through that information through a wall of text on degradation phenomena. Glass is actually a really nice one in terms of this classification system, because using it, you can then draw out certain observations. For example, if you've got a load of blue sheds, which are all scoring in good condition, and then you've got perhaps a load of red-coloured glass sheds, which are all poor, you can then sort of make observations as to what the composition is that's causing that. And then copper alloys, very similar to iron, looking at the extent of mineralization and also how much active corrosion you have. So this is a lovely brooch, and this was the assessment before. And this is the assessment after. So again, the key information is really pinpointed. It's readily accessible for a specialist. The features of the object are described, but there's not further designation of typology. Other materials that are present, like the enamel in this case, are described, and you know it's waterlogged. So everything is there for you. You're not having to look through pages about the green corrosion, which you would anticipate anyway. So using a classification system, there are some massive benefits. So it streamlines the condition assessment process. Previously, I would have allocated about 10 minutes per small find. Now I allocate about 5, so that's a huge difference. It makes the data relevant to other specialists more easily accessible. And it allows us to quantitatively, and I hate that word, I always get it wrong. I apologize in advance if I do. It allows us to quantitatively analyze the data from a site. For example, if all the glass from a site is scoring poorly, odds are it's probably medieval. Or, if the iron is good, but the organics particularly bad, that gives us a bit of an idea of what's going on in the burial conditions. Of course, there are always some limitations. So Taylor illustrates that there is scoring variability in condition surveys. Arguably, a normal condition assessment can be quite subjective as well, but when you're assigning a score, different people might score differently. We did carry out a short experiment with some of our placement students and ask them to analyse the same assemblage of object and give a score, and we did find some variability. It's also not as appropriate for smaller assemblages. So we tend to only use it for more than 50 finds or more than 50 finds. Part of this is you might have a small assemblage from a test pit and there's not enough finds there to give a reliable data set to draw any reliable conclusions. So in those cases, we do the full condition assessment to give archaeologists a bit more of a better idea of what they might find if they do a full excavation in that case. So improvements to the method with those limitations in mind. So the big thing we do is we make sure one conservator is assessing all of the same material class. Even if we have a massive assemblage, one of us might be assessing the iron and another person might be assessing the amber and jet, but we don't mix. And that gives a bit more reliability in that particular data set. The other thing that I've been doing is adding reference photography. So this gives a visual example of what you might expect to be seeing. And there is a nice collection of amber beads with the different condition classifications. I also have some do's and some things to avoid. So, do identify any unusual degradation. There are certain forms of degradation which aren't common, so we don't include them in the classification system, but can tell you a lot of information about a particular assemblage. For example, if you've got the deep red corrosion layers in iron, there's a good chance that it might have been burnt, so we make a note of that. A description of any features, a note of any MPOs, and then make general classifications like this is a nail, this is a coin, this is a brooch. Avoid. Changing assessor mid-material, it reduces the reliability slightly. And identify specific typology. Again, from that museum background, I've often found that a label given to an object can last a very long time, whether or not it is correct. So I am loath to give specific designations to objects, unless of course you have the expertise to do so. Otherwise, please refer straight to a specialist, don't pass go. And these are the materials that we have so far. So we have copper alloy, glass, iron, lead, shale, silver and stone for the inorganics. And on the organics, we have amber, worked bone, horn, ivory, textile and waterlogged leather. And this is the classification system. So it's still a work in progress. There are still materials to add. As a commercial conservation laboratory, we don't have much control over what it gets brought to us. And even if a material class that's missing does get brought to us, if you've got a site which has got a lot of jet, the odds are it's probably in quite good condition because it's survived. So you might not have the full condition range. So I'm presenting this now in the hope that we can get some collaboration. Do you have some expertise in a missing material that's not listed here? Please get in touch. I would welcome input. Or do you have a collection of really gnarly horn, like tucked into your store, which would make some really good reference photography? Let us know, please. This poster is available as a PDF. My email and the conservation email is available on the next slide. Please email me, or we have a stall downstairs. Please let us know. Make use of it. See what you think. I would really like some feedback. And that's everything.